This is Geometry, Unit 4.6. This is our second day. We're going to be working with proofs, proving triangles congruent. So when you work on a proof, what we always talk about is don't worry about the two columns yet. Always start with the given information and where that is in your figure. So angle G is congruent to angle B. They already have that labeled in the figure. Segment CB is parallel, that's what the two dashed lines means, parallel to GA. And because they have arrows here, you can emphasize that a little bit if you like. They have arrows on their lines. That indicates that they are parallel to each other. Parallel does not mean congruent. You can be parallel and not be the same length. Now, every time we hear the word parallel, we're supposed to think about one of our four types of angles. So which type of angle do we have? This happens very often, that the type that we're looking at, going down the parallel line, down the transversal, and down the parallel line, is going to form the zigzag. Those are alternate interior angles. That's where this angle is congruent to that one. Alternate interior angles will be congruent. We know that because the lines are parallel. So once we do that, we now need to find one more bit of information. Can anyone look at this figure and identify one piece of information that we haven't discussed yet that has to be true? The middle segment, we call this the reflexive side because it is in both triangles. CA in this triangle is going to be congruent to AC in that triangle. Now I have a 1 ticker in both triangles, a 2 ticker for the angles in both triangles, and the same segment in both triangles. Angle, angle, side. I already found out how to prove the triangle is congruent. So you make your plan first before you start to work on your proof. They've already filled in our given for us, so of course we know that just because the given tells us. Notice that it tells us about parallel lines, so we're going to talk something about what happens with parallel lines. If lines parallel, then alternate interior angles are congruent. If the lines are parallel, then alternate interior angles are congruent. If has to come earlier, then is coming right now. Angles are congruent, and that's what we're talking about. This has us working with the reflexive property of congruence. From the 2 ticker down to the no ticker in this first top triangle, that could be called C to A. In the other triangle, going in the same order from the 2 ticker up to the no ticker, that would also be A to C. So we would need to name that one backwards. It's not a requirement to switch those letters, but it's a good pattern so that you can look here and see CA and you can see AC. They're in the same order in the triangle names, same position. Your last statement is always what you're trying to prove. It's always your last statement. So triangle GCA is congruent to triangle BAC. Now, why are the triangles congruent? We have 4 ways to do this. What we looked at, we had an angle, then we had another angle, then we had a side. Angle, angle, side. Remember, the parallel does not count as a side in terms of congruentness. So we have congruent angle, and a congruent side. So that is AAS Congruence. Let's come down to our second one. Pause the video, come up with a plan on how you're going to prove these triangles congruent. I'm actually going to draw the figures separately because they are overlapping each other. That might be benefit for you, so you could label them cleaner. But you go ahead, come up with a plan on how you're going to prove these triangles congruent. All right, we're back. So when I look at what we're trying to prove, I notice that we're looking at MJN. This triangle in here, we can trace that out if we like. If I can find my highlighter. That triangle, it is overlapping with NLM. Since it's overlapping, I'm going to draw them separately. I would suggest draw out your triangle with JNM. And then we'd come over and we draw out, trying to get our lines about the same. That would be NML. So here, the given information tells us that JMN, that's this angle up here. J to M to N is congruent to L to N to M. If we were to do those markers over here, it would be a little difficult to be able to see that. And it's tough to tell just where the curves are and which triangle are we in, and it gets a little complicated. Here it's pretty straightforward. The other angle we're looking at is JNM, from J to N to M. That would be this entire angle. So there's even more confusion. Now we have these two figures overlapping. It's hard to tell which angle is which angle. So drawing the picture separately can really help you. And that's going to be congruent to LMN. Now, the one trouble with drawing them separately is that we can't see if we have any shared pieces. So looking back at the original, are there any pieces that are shared? J and M and N and L. I see that these two segments are crossing over. They do cross. Some people might say that they form vertical angles, but vertical angles are not part of the actual triangles themselves. The O is not one of the corners of the triangle, so we're not looking at those angles. So no, we don't want to consider anything to do with vertical angles here. Anybody else see a piece that is the same in both? If you look here, both triangles share this segment that goes back and forth here. Both triangles have that. So this segment is going to be the same as that segment. And I can look to notice here that angle side angle is the way we would prove the triangle is congruent. So we've come up with a plan. That's the toughest part. So we're going to start out with our given information. Angle JMN is congruent to angle LNM. Angle JNM is congruent to angle LMN. That's our given information. That should be the easy one. Everyone can do that. Those are the two angle pieces that we marked in our figure. Then we talked about this additional side, the side that was the same in our figure. What is that called? What do we call it when it's the same shared piece? Reflexive. Reflexive property of congruence, POC, property of congruence. Then we're going to end with our congruent triangles. And we need to give a reason. We have 4 different reasons so far. What's the reason that we notice here? Come up to your figure and try to look at what you know. We have an angle, followed by a side, followed by another angle. 2 angles and the included side. Angle, side, angle. Congruence. Now here our picture kind of got moved over, not sure what happened there, but if you look at what we're trying to prove, we're trying to prove that ADE, that triangle, is supposed to be congruent to another triangle, BEC. So those are the 2 triangles that we're going to be working with. Since we have these additional lines involved, I would suggest to draw those 2 triangles separately. That would be A, D, E, and E, C, B. So those are our 2 triangles that we're working with. They're telling us from our given information that AE is congruent to BE. So you want to label that on the figure. Tonight's homework is all going to be about labeling the picture. Then we have angle ADE. That's this one. Remember, the middle letter is your vertex. So from A to D to E. We couldn't use just one letter because in the original figure we got too much happening at D. We got multiple angles being formed at D. And that's supposed to be congruent to BCE. Now that's all the given information they show us. Is there anything else we know for sure? Nice job. Vertical angles at point E. You notice that that is actually a corner of our triangle. So we want to talk about those as vertical angles. Since E is a corner of our triangle, this is where this becomes important. So this angle E is going to be the same as that angle E. And we'll need to use 3 letters to name that angle in our proof. All right, now I can notice that angle side is how we're going to prove the triangle is congruent. So I'm ready to do my proof. We have our given information. Then it wants us to talk about the vertical angles. How are we going to name these angles? I'll give you a hint. You cannot say angle E. BEC, that would be correct. Angle BEC is congruent to angle AEC. That is excellent. Oh, correct. AED. Good job. The letters matter. You can't just put down any letters you want. All right, so now what you're trying to prove is triangle AED is congruent to triangle BEC, and we have one of our 4 ways we do that. This is the only thing you can put here. We have angle followed by the non-included side. So AAS Congruence. One more example. So pause the video, try to come up with a plan for why these triangles are going to be congruent. Take your information, plug it onto your figure, mark up your figure, and find any additional information you know. All right, we're back. We're looking at ST and TW. This shows that it's perpendicular. That means it's going to be a right angle. VW and WT, those make a right angle. That's going to be perpendicular. Angle VTW, that would be this angle, is going to be congruent to SWT. That's that angle. And then if just by looking at the figures, I can see that the side they share would be the same, and we call that reflexive. So the triangles are going to be congruent by angle, side, angle. We have our given information. Now here's our step that we always want to talk about when we are coming from perpendicular. If perpendicular lines then right angles. Now look at the reason we have for statement number 3. Right angles are congruent. I would prefer this to be an if-then statement. If right angle, then congruent angle. That would be better than this right angles are congruent. We write our statements typically in if-then form. But what is this talking about? What type of answer am I going to put here? What's the then part of your reason? Congruent angles. So angle STW is congruent to angle VWT. Then we have our reflexive side. And the way we prove the triangle is congruent. Good job.